So one more thing I would like to point out is if you are interested in developing applications in cloud and in Azure, the best starting point would be this Windows Azure training course. So Microsoft provides a lot of lot of hands-on labs, samples, and presentations, and all of them are under Apache license, so you can even reuse the code that's there. So that would be a very good starting point for your applications. So yeah, so you can download it for your offline usage, and then you'll get these lot of tutorials, lot of labs. So they focuses on different aspects, so you can do the lab whatever the aspect you want, and then get up and running with your application. And it also has these code samples and presentations. So some slides from this presentation are even used in my presentation as well.
And then you should ask if there are any questions.
Yeah, so is there any questions about us?
Can you see if the other sites have questions?
I'm working on it.
Yeah, come.
So the earlier talk is about Amazon. So this is Azure. How much price difference you guys want to run the same application?
Okay, the question was, so earlier we talked about Amazon EC2, and then now we talk about Azure. So what's the price difference? So I actually would say it's dependent on the application. So if you look at the raw VMs, so if you look at the Windows VMs in EC2 and the Windows VMs in Azure, the price is more or less the same. But if you look at the raw compute power, I have seen that the Azure has a little bit more compute power than the Amazon instances. For example, in Amazon, if you go for a medium instance, you will be billed for, I'm just talking out of my memory. So I think you will be billed for 4 EC2 compute units, but you are getting only 2 actual cores, 2 actual physical cores. But in Azure, when they bill 1 compute unit is mapped to a actual core. So there's a possibility, depending on the application, you might get better performance and better cost efficiency in Azure. But on the other hand, it also depends on whether your application will perform better with Linux or will perform better with Windows, those kind of scenarios as well. Any other questions? Yep.
Yeah, if you want to install some Office software or some Visual Studio on the Azure cloud, is there some license issue?
So the question is whether if you are installing Office or Visual Studio kind of software, is there a license issue? I would imagine so. The other thing is like Azure provides remote desktop connections to Azure instances, but I'm not really sure how usable it would be to use a GUI application, like a user application like Office or Visual Studio in the cloud. But if I remember correct, Microsoft has this software as a service offering called, I think, Office 365, where you can use Office applications. But on the other hand, if you look at things like SQL Server, those kind of scenarios, you pay only for your usage, and the licensing costs are covered by them. And then even when you're using Windows instances, you pay by hour, and the licensing costs are included in that. So similar to that. Thanks. Yep.
How good it is for multidimensional data?
So the question is how good it is for multidimensional data. So you mean
you have only 2 keys you can use for indexing, partition key and row key. So what about if the data dimension rate is high?
So I don't think you can. So the question is how good Azure tables would be for multidimensional data. So I don't really think like you can have native support for that. But you can maybe use a combination of Azure tables together, and maybe you can achieve that. So the other option would be trying to go for this SQL Server, it's called SQL Azure, which is the Microsoft SQL Server hosted on cloud. So that would be one option. In terms of storing raw multidimensional data, I'm not really sure whether you can natively support, but maybe you can use a combination of tables together and so to achieve your objective. Yeah, thanks.
This question comes from UCLA. Are there any free tools to create virtual images for Azure, similar to the ones we have for
Okay, so the question was, is there any free tools available to create virtual images for Azure? So actually, so if you're using worker roles or web roles, you don't really have to create a virtual instance of VM image. You just have to create your deployment bundle. So that doesn't contain an image. It will contain only your code and the configuration and those kind of things. And then you can deploy it. So as far as I know, so one way to do that is to use Visual Studio. And as far as I know, there's a free edition of Visual Studio. I think Visual Studio Express it's called. So you can use that. And then also on the other hand, Azure provides these other SDKs as well. So the Java, PHP, and all these SDKs. So I'm pretty sure you can use them to create these deployment packages for Azure, and they're free. Yeah. So so actually, there's one more thing, the VM roles. So I think you can create it for free, but I really don't have any first-hand experience with VM roles. So the VM roles would require a virtual machine image, but I don't have like a first-hand experience or clear understanding how the pricing would work in that scenario, and how the licensing would work. Thanks. Any other questions? Okay. Okay, then let's move on to the Twister4Azure presentation. I think we might run out of time.
You started late.
Okay.
We'll let you know. Okay?
Sure.
If we have an afternoon break, then
Okay, so we're going to. Okay, great. Okay, so now I'm going to present Twister4Azure, which is an iterative map produced for Windows Azure Cloud, which we developed in Indiana University. So to give a brief overview first, so Twister4Azure supports a distributed, a decentralized iterative MapReduce architecture for clouds. So this avoids single point of failures. And then Twister4Azure uses the Azure Cloud Services as the underlying building blocks. So this will this enables Twister4Azure to utilize the high availability and the scalability of the cloud services. And then internally in Twister4Azure, we have taken measures to take care of things like eventual consistency and other drawbacks which cloud services offer. So when you're using Twister4Azure, you can get all the goods from the Azure cloud, and then the framework will take care of all the fine-grained issues you have when using the cloud. So Twister4Azure extends the traditional MapReduce programming model with iterative extensions. We'll have a look at the more detailed look at the programming model in the later slides. And then Twister4Azure supports multi-levels of data caching. So this makes your applications run much faster when executing in the clouds. And another feature Twister4Azure supports is having multiple MapReduce applications per job. So for example, if you have a iterative MapReduce application, and then if you want to use more than one MapReduce application inside an iteration, so Twister4Azure supports scenarios like that, and then it supports sharing cache data between these applications that are running under a single iteration. And you can also use this feature to create simple workflows as well, like for example to execute dependent jobs, similar to what Hadoop provides with job control classes. So a new feature we are implementing in Twister4Azure is the collective communication primitives. I'll touch on that in a later slide. And so currently Twister4Azure outperforms Hadoop running in a local cluster by 2 to 4 times. This is when you think of these performance results, you have to think that Hadoop has been running on a bare metal local cluster, which has even per single compute node, which had more compute power, and then had dedicated hardware and dedicated network interconnects. And then Twister4Azure running on the Azure shared environment with shared network, shared compute resource, and it was able to outperform Hadoop by 2 to 4 times. So other than that, Azure features dynamic scheduling, which supports much better load balancing, and then provides the users with typical MapReduce fault tolerance, the web interface to monitor the jobs, as well as the local testing and debugging support using the Azure local development environment I mentioned in my earlier talk.